Alrighty, this, a little bit. There we go. All right, I'm going to give just a couple minutes for folks to get in and get settled, and then we're going to talk about my math lab, how homework's coming due, and then we'll talk about logarithm properties. I am also uploading these videos. I'm recording them on my own machine now, and I'm uploading them to YouTube because I know there've been a lot of problems with Zoom's cloud not actually providing access to the videos when they should. So right now I'm uploading my MAC1105 lecture from earlier this morning, and I'll go ahead and post a link to the recording, the same place I've been posting the links to the Zoom recordings. It'll just be a YouTube link instead. So today we're going to start exploring section 5.5 a little bit. We're going to talk more about section 5.4 and the stuff that's in homework 19. But then we're also going to talk about properties of logarithm functions and a little bit of solving equations. So once folks have had some time to arrive, we will dive in. I guess while we're waiting, I'll clear the board. I'll put up some announcements. So homework 19, the first homework on logarithms, the one that you guys started on last week, that's been extended to next Monday. So it's the 13th. And then this week, homework 20 and homework 21 open today. And these are due also on the 13th, so also on next Monday. I will probably end up pushing them back one more week. I'm going to keep track of how many folks have completed it and where we are in our progress, because I don't want to go too fast. But I also don't want to go too slow. So if we need to extend homework 20 and 21, we will. If we don't, then we won't, because we do still have a fair amount of other material to get through once we're done with logs. The last topic in this class, after we're done with logarithms, properties of logs, and solving logarithm and exponential equations, is systems of equations and systems of inequalities, which is a fairly easy topic. I think it'll move quite quickly, and then the last exam will probably be something like a project or a take-home instead of doing one of those high-pressure exams. But we do have one more high-pressure exam, exam 3, which is going to be on exponential and logarithm functions. So I'm hoping that you guys are putting some real time and real effort into the homeworks 19, 20, 21 this week. There's also a quiz. I think it's labeled quiz like 5.4, 5.5, 5.6, something like that. This is opening today and is scheduled to be due on the 13th. But I will do the same thing with the quiz that I do with this homework. If we need to extend the homework, then I'll extend the quiz too. I've gotten a bunch of emails about the assignment in my math lab that's showing up as final 1. Don't worry about that. What that is that's a first draft of the online version of the final exam for this class that the College Algebra Course Committee is working on putting together. It's there so I can look at it. It's password protected, you won't be able to get in, and it's not something you need to worry about. I will definitely talk with you guys lots and lots and lots before anything to do with any exam shows up in my math lab. So please don't worry about that. If you already sent me an email, that's fine, you know, but if you feel compelled to send me an email in the future about that, please just relax. I know it says it's going to be due today. That's a reminder for me to go in there and take a look at it and to critique it and to offer feedback to the person who wrote it. Any questions about MML stuff? Okay, if not, then today what we're going to talk about is a slightly more advanced perspective on logarithms. So we're going to look at some properties of logarithms, and we're going to start learning how to manipulate them algebraically. So remember, the useful definition of a logarithm for us is that y is equal to the base a log of x means the same thing as saying that when you raise a to this power, you get x. In other words, the base a logarithm of x is the power to which you must raise a in order to get x out. I'm going to give you now the four crucial algebra properties of logarithms. I want you to devote a whole page in your notes to these, even though they won't take up too much space themselves. And then I want you to put a little sticky note on that page so you can flip to it quickly. Because for the next week and a half or so, these properties are your God. If you're religious, please don't take offense. I don't mean that literally. The first, and it's one that we've seen in some other settings, that the base a log of a raised to some stuff, and here instead of writing the word stuff or the word shit, I'm just going to write the variable x, but with the understanding that x could be anything. It could be a variable, it could be a number, it could be a combination of numbers and variables. This is just x, because the base a logarithm is the inverse of the base a exponential. And then the other kind of version of this is that if you take a and you raise it to the power of the...
Professor, it's really blurry.
You also get x. So let me step out of the way. The camera usually will focus on the board if I get out of the way. Can you see this better now?
Yeah, way better.
Way better. Okay, yeah. I'll try to remember to step out of frame each time I write something so the camera can focus. If you have trouble seeing, do just what you did. That's perfect. Just go ahead and let me know. And I'll step out of the way.
Is there another light that you can shine on the board?
Yeah. Is that better?
Better than before.
Okay. Here, let me. Sometimes we have problems with glare too, so it's a difficult balancing act. But yeah, there we go.
Do you have a black marker?
I don't. Nope. All my markers are dying. I'm cycling through the best ones that I have right now. So I can try black here, but I'm pretty sure all of my blacks are super duper dead. So the next important property of these things, oh, this one's doing okay, is that if I take the base a log of some other power, so this base and this base don't match, then what happens is that this variable here, or whatever it is that's up here, is going to come down in front as a multiple. So a log of a power is the same as that power times the log of the base inside. Is the black better?
Yes, thank you.
Okay, good. The first property can actually be seen as a consequence of the second, because the base a log of a is 1. And it's the second version that we're going to use most of the time when we solve equations. The third property is that logarithms take multiplication inside and turn that into addition outside. So the base a log of a product, x times y, and x and y could be anything, numbers, functions, whatever, is the base a log of x plus the base a log of y. So multiplication inside is the same as addition outside. And then there's one more. If that's what logs do to multiplication inside, then what should they do to division inside? Multiplication inside becomes addition outside, then division inside is going to become subtraction outside. I'm trying to mash this marker into the board because it is going to die. So these 4 properties of logs, super duper important. The last 2 are very easy to use incorrectly. The last 2 are super easy to get confused about. And that's why I say you need to have a full page in your notes dedicated to these, and then put a little sticky tab there so you can flip back. So every time you want to use one of these as you solve the homework problem, flip back and make sure you're using it correctly. For example, there is no rule that takes the log of addition inside, like the log of x plus y, into anything. There's nothing we can do with addition inside. And there is no rule that takes multiplication outside anywhere. There's nothing I can do with the log of x times the log of y. There's one last kind of thing I want you to put on this page, and that's the change base formula. So you remember last week we solved the equation 2 to the x equals 3, and we got the base 2 logarithm of 3, but we weren't able to get a feel for how big that number is because my calculator doesn't have a base 2 log button. Some do. I think the TI-84 and newer have a arbitrary base logarithm function, but not every calculator has that. And so we need to be able to go from weird bases to normal bases. The 2 bases that we use a lot, remember, are 10 and e. The base 10 logarithm we call the common log, and we just write log with no base. And the base e logarithm we call the natural log, and we write ln. Here's a rule that lets you take any base to any other base. If somebody hands you a base b logarithm, but you want a base a logarithm, the way you change the base b log of x into the base a log of something is this rule. You take the base logarithm that you want of the inside, and then you divide it by the base logarithm that you want of the old base. So the first example I'm going to work, we're going to go back to the equation 2 to the x equals 3. We're going to solve it again. This time we'll be careful with these log properties rather than trying to get there just with the definition. And then we're going to use the change of base formula to approximate that number as a decimal. So please give these things a special place in your notes. And make it possible to refer back to them regularly. And then as you use them, refer back and make sure you're using them correctly. I know that the equation 2 to the x equals 3 has a solution. 2 to the x is a continuous function. 2 to the 1 is 2. 2 to the 2 is 4. So somewhere in between x equals 1 and x equals 2 is a number that will make this true. If I take base 2 logarithms on both sides, and really I could take any base logarithm I want, but I'm going to take the base 2 log because this is the base 2 exponential. It's like squaring both sides or taking square roots of both sides. It's an operation I can do to both sides of the equation, and the equation will remain true. I get log 2 of 2 to the x equals log 2 of 3. And I can use that first property of logarithms to say that the log 2 of 2 to the x is just x. So, or I could use the second property to bring this x down front and say this is x times log base 2 of 2. And the right-hand side is still the log base 2 of 3. Now the log base 2 of 2, that's 1. This guy right here is 1. Because the base 2 logarithm of 2 is the power to which I need to raise the number 2 in order to get 2 out. And 2 to the 1 is 2. So in other words, this just reads as it would have if we used property 1, x equals log base 2 of 3. But if I want to figure out how big this number is, if I want to get like a decimal for this number, I look down at my calculator and I realize I only have 2 logarithm buttons. One says log, the other one says ln. So in order to get a decimal out of this with our calculator, we need to use this formula. I can write this as log base 10 of 3 over log base 10 of 2. In other words, here b is 2, x is 3, and I choose a equals 10. Because I have a base 10 log button on my calculator, it just doesn't have the 10 written. That's the common log, the log. So now, along with me, grab your calculator, find the log button. It's the one right below the x squared button. Type log of 3, close the parentheses, then divide log of 2, close the parentheses, hit enter. You get 1.58496, blah, blah, blah. (962501). Now check this out. I could have turned that into a natural log instead, using this same rule. This is the same as ln of 3 over ln of 2. You have to be careful with the division. Make sure that you close those parentheses before you divide. But separate from this, go ahead and type in ln of 3, close parentheses, divide ln of 2, close parentheses, hit enter. You get the same number. So this means if I take 2 and I raise it to this power, I should get 3, or something very, very close to 3. So to do that, I hit 2, and then the button above the division symbol, it's like a little upward pointing arrow called a caret that gets you into the power. Then open the parentheses and type 1.58496251. And I get out 3 point many, many, many zeros and then a 1. This is very, very close to 3. And this is the big deal with logarithms. Logarithms let us take equations that have variables in the exponent and turn them into equations that don't have variables in the exponent, brings the variable down out of the exponent. And that makes exponential equations solvable, whereas before they really weren't. Unless we could kind of guess our way there, or use the one-to-one property and kind of algebra our way there gently, we couldn't handle these, and now we can. Questions on this example, or the change of base formula? So I'd like to look at one or two other problems, if there aren't any questions, and sort of build our way up to, what the hell? Build our way up to the more complicated stuff we'll see in the next section. Why is the base 2 log of 2 equal to 1? It's a fair question. So go ahead and look at the definition of the logarithm. Remember, y is equal to the base a log of x is the same as saying a to the y equals x. So if I want to evaluate log 2 of 2, I can call it y, and then say, okay, well, y equals the base 2 log of 2. That means 2 raised to the y equals 2. In other words, this number, the log base 2 of 2, is the power to which I need to raise 2 in order to get 2 out. 2 to what equals 2? Well, 2 to the 1 equals 2. So the base 2 logarithm of 2 is 1. Fair question. It's an important step in this. And in general, the base a log of a will always be 1. What else are we wondering about this example? Feels weird. Anything else feels okay? All right, let's look at a slightly more complicated example. This is the 19th problem in homework 19. This isn't approximately equal to 1. I just erased everything that came after the decimal there. So homework 19, problem 19, asks you to solve the equation 4e to the x plus 5 equals 7. So in order to get to a place where we can use logarithms on this, I need to turn it into an equation like that. I need to turn it into exponential equals constant. So I got to get rid of this 4, I got to get rid of this 5. I need to get the e to the x part alone. First step there is going to be to subtract 5 from both sides. So that will give me 4e to the x equals 7 minus 5 is 2. And now we're almost there. I just have to get rid of this 4. Right now the 4 is multiplying e to the x, so to get rid of it I divide. Dividing both sides by 4, I get e to the x equals 2 divided by 4 is 1/2. And now in order to finish things up, I take logs on both sides, right? Take the log of both sides. I have to pick what base logarithm to take. Since this is a base e exponential, it makes sense to take the base e logarithm of both sides. Well, remember that has a special name. That's called the natural logarithm. So I'll take the ln of both sides. So now I take logs. The log I choose to take is the natural log because this is the natural exponential. And when I do that, this is what it looks like. It's just both sides are now inside of ln. The ln of e to the x, according to our first property of logarithms, is the base e log of e to the x just becomes x. The ln of 1/2 is the ln of 1/2. And I can approximate that in my calculator. I go down to the ln button. It's the third from the bottom on the left. And I type 1 divided by 2, and then I close that parentheses. I want the 1 divided by 2 inside the ln. And that gives me negative 0.693147, blah, blah, blah. This is what we call a decimal approximation. It's not the exact value. This is what we would call the exact answer in terms of logarithms. There will be problems where I ask you just for the decimal approximation. There will be problems where I ask you just for the exact answer in terms of logs. And there will be problems where I ask you for both. So you need to be comfortable not just with the calculator work, but also with the algebra work that we're doing by hand. In fact, I would say that the algebra work that we're doing by hand is way more important. Questions about this example? Excuse me. Any questions here? So ln and e always cancel each other out. It's a little bit dangerous to think of it that way. But I hear people say that a lot. The natural log of e to some stuff will always just be that stuff. And so in that sense, they do cancel. But it's not canceling in the same way that we cancel with fractions. It's a different operation. It's a function composed with its inverse. So they undo each other. But if you want to think of it as canceling, that's okay. Just be very careful and make sure that you're using those properties exactly as they're described. So yes, but with a caveat. Let's look at something a little trickier. Excuse me. So number 22 from homework 19. Here you're given a real world situation, albeit a bit contrived. You're asked to come up with a function that models some real world phenomena, and then you have to answer some questions about it, which will involve solving exponential equations. So we say that a substance consists of C grams, and it grows at the continuous rate of 17.3% per year. This is homework 19. Question 22. I really don't like these problems a lot where you talk about a continuous growth rate because they feel a little bit contrived to me. But remember that when you see continuous rate, it's the same thing as continuously compounded interest. So we're going to use that PERT formula. They ask us to find a model of the amount A of the substance left after X years. So the amount A of X present after X years is going to be A of X equals, well, so the formula first is P e to the Rx. Remember, it's the same as the PERT formula, only here we're using our variable X instead of T. The initial amount is C grams, and they haven't told us what C is, so P is just the constant C. R, they have told us. This is growing at a rate of 17.3% per year, so that's 0.173 for R. And then X is my variable, so it's just X. They ask, how many years will it take to double the amount? So this is part A. Part B says, how long to double? If I start with C grams, then having doubled means I'll have 2 C grams. So I need to solve the equation C times e to the 0.173x. That's the amount there is after X years. I want to know how many years, or for what value of X, is this equal to the double of the original, which is 2 times C. So I need to solve this equation. First, divide both sides by C. The C's will cancel. So dividing both sides by C, I get e to the 0.173x equals 2. And now I take logs. I'm going to take ln of both sides. So I get the ln of e raised to the 0.173x equals the ln of 2. Taking logs just means put both sides inside a logarithm, just like taking square roots on both sides. Now this power is going to come down. The ln of e to some stuff is always just that stuff, and you can think of it 2 different ways. You can think of the ln and the e canceling, like John said, so this would be 0.173x. Or you can think of it in terms of the second property that says even if those bases didn't match, this guy would come down. So I would have this times the ln of e. And then the right-hand side is still just ln of 2. But because these bases do match, e is the base of the natural logarithm, this is just 1. The ln of e is 1. Because the power to which I need to raise e in order to get e out is 1. Either way, you arrive here. 0.173x equals ln of 2. And the magic of the logarithm is that this exponential equation, which had the variable stuck in an exponent, becomes this linear equation. Right? Here I just have some constant times x equals some other constant. ln of 2 is just a number. So I can divide both sides by 0.173. And that gives me this. I'm going to switch over to the virtual TI-83 so you guys can see me do one of these calculations. Oh, and I see that there is a question. Why don't we include both of the 3's in the 0.173 number? I'm not sure what you mean by both of the 3's. So there's just one 3 in 0.173. Did I leave a 3 off somewhere? This is a percent symbol here, not a 3. Is that what you mean, or? Is there something that's hard to read? Oh, nope. Yeah, perhaps I misread the problem. Nope. Yeah, this is all good. Yeah. Sorry. Yeah, that's just a percent symbol. That's all. So let me fire up my virtual TI-83, and then I'll screen share that with you guys, and you can see how I would put this in the calculator. All right. So I want to enter this number in the calculator. I need to be careful with my parentheses. The 2 needs to be inside the log, but the 0.173 needs to be outside the log. So I turn this on. I type ln of 2, and then I need to close that parentheses before I divide by 0.173. Yes, ln parentheses 2, close parentheses, divided by 0.173. So it's going to come out to 4.006631 blah, blah, blah. For this problem, the decimal is nicer. So we want to go ahead and enter that in the calculator and then record the decimal that comes out. But we need to keep in mind that this is an approximation. It's not exact. So 4.0063 blah, blah, blah. And again, this is the exact answer. This is the approximation. And then if you look, you can see the previous line in my calculator there was where I was showing something similar for another class. Just make sure that you're very, very careful with your parentheses as you use these logarithms. Just like in the previous homework, when you were using that compound interest formula, you had to be super careful with your order of operations. There's a similar risk here of making order of operations mistakes if you don't use parentheses very carefully. Yeah, we'll always make sure to ask either for an approximation or for the exact answer in terms of logarithms. So it'll never be unclear which is desired from you. Okay. We have time to look at 1 or 2 more. So the last problem in your homework 19 says that a pot of boiling water with temperature 100 degrees Celsius set in a room of 20 degrees Celsius. And then they give us a function. Am I writing the test out? I'm not sure what you mean by that. So your exam 3, I will be writing, yes. I will put it in my math lab. So it's going to be an online test that will be proctored using HonorLock. We're still a little ways away from being ready for it. So it's not going to be at the same time it was scheduled on the syllabus. I think the syllabus had us scheduled to do that this week, or maybe even at the end of last week. But with all of this coronavirus madness, we've been pushed back a little bit, and that's okay. The test will probably be early next week, but I will talk more about that with you guys as we get closer. So the temperature, this is homework 19, problem 26, of some water, X minutes, hours, after being taken off the stove, is, and these markers all sub, T of X equals 20 plus 80 times e to the negative x. I would like to know how long to cool to 50 degrees. So if this is the temperature after x hours, and I want to know how long will it take to cool to 50 degrees, I need to set this equal to 50 and solve for x. So I need to solve 20 plus 80 e to the negative x equals 50. First, I'll subtract 20 from both sides. So the game is going to be to get the e to the negative x alone and then take logs. Isolate the exponential and then take logs to undo the exponential. So if I subtract 20 from both sides, then I get 80 e to the negative x equals 50 minus 20 is 30. And then I divide both sides by 80. And that will give me e to the negative x is equal to 30 by 80 is 3/8. And now again, I'm at this good step where I've got my exponential alone, so I can take logarithms on both sides. So from here, I get the ln of e to the negative x equals the ln of 3/8. The ln of e to the negative x is just negative x. And now I divide both sides by -1, which is the same as multiplying by -1. So here's my answer. This is my exact answer in terms of logarithms, but I don't have a feel for how big that is. So I'm going to switch back to the screen share really quick again to show you what that looks like in the calculator. I would type negative, oh, sorry, turn it on, clear it up. Type negative ln of 3 divided by 8, and then close that parentheses. And I get out 0.980829 blah, blah, blah. So I'll round that to 0.983. Oh, 9808. So we'll call that 0.981. These are the number of hours it takes for that pot of water to cool down. Now I want to show you something cool. Our second property of logarithms said that if I had a power inside, I can bring that down front as a multiple. You can actually use that in either direction. So I claim that the negative ln of 3/8 is the same as -1, of course, times ln of 3/8. I don't think anybody has a problem with negative as being the same as -1 times. But then I could bring this inside as a power if I wanted to. So that's the ln of 3/8 to the -1 is 8/3. And if I go back to my calculator, 3/5, should it be 3/5? No, 30 divided by 80 is 3/8. We started setting the equation equal to 50, then we subtracted 20 from both sides. 50 minus 20 is 30, and then we divided both sides by 80. 30 divided by 80 is 3/8. Yeah, so 3/8 is correct. But the fun thing is bringing this power, this constant out front, inside as a power. So now I'm going to also calculate, that's all right, yeah, my handwriting is not perfect. So check this out. We have the negative ln of 3/8. I claim that's the same as the positive ln of 8/3. Boom, same thing. So this last step here, this is using that second property of logarithms. And this is what homework 20 is all about. Homework 20 is going to be all about rewriting logarithm expressions in different ways using those properties. And it's going to take some practice. It's going to feel really weird at first. The key is to make sure you have those logarithm properties written down clearly and correctly somewhere in your notes that you can refer back to. And every time you're tempted to use one of them, make sure you're using it correctly. They only work the way they were given. They do not work any other way. Sorry, I'm starting to lose my voice. That's where we're going to leave it for today. So homework 19 from last week is still open. It's going to stay open until next Monday. Homeworks 20 and 21 are now open. And on Wednesday of this week, next time we meet, we're going to talk more about properties of logs, this sort of thing, and also how to solve exponential and logarithm equations that are a little bit more complicated than the ones we're seeing today. Any sort of last minute questions or curiosities before we wrap it up for today? All right, so I am recording this on my computer, which means that the recording should come out a little bit better, and I'll host it on YouTube so you don't have to deal with Zoom being retarded and saying things are up when they're not actually up. The downside is it might take a little bit longer for me to get the link there. So I will post the link to this recording. It will be a YouTube link instead of a Zoom link to the announcement where you found the link to this stream. To set up a meeting, yeah, send me a Canvas message, or you can just drop in the office hour. You don't need to set up a meeting to do that. So tomorrow I have a 9 to 11 office hour that you're welcome to just come into. And if you want to meet outside of office hours, sending me a Canvas message is perfect, yeah. Awesome, awesome, really glad. Okay. So everybody keep working hard. Once you get through homework 19, just go ahead and start on homework 20. You've got everything you need to finish all the homeworks now. So the next couple days are just going to be practice, lots and lots of practice. Work hard. If you need help, don't be shy about reaching out, okay? All right, I'll see you guys either tomorrow in office hours or on Wednesday.